This video is about forces acting on a rocket as it launches, after it's launched, and while it's in orbit.
Start, 2, 1, boost ignition, and liftoff of the Space Shuttle Discovery, returning to the space station, paving the way for future missions beyond.
Forces play a really important part when a rocket launches, so there are balanced and unbalanced forces and there are interaction pairs that we can consider. So this activity takes into account all of the different forces that are in play before the rocket takes off, during the launch, and once the rocket is in orbit. So what you need to do is for each period in the takeoff of the rocket, before, during, and during orbit, you need to do each of the things down this column. So the first one is to draw a picture. So this picture's already been done for you, and this is a picture of the rocket before takeoff. Using a pencil, you need to draw an image of the rocket during takeoff, an image of the rocket when it's in orbit around the Earth. Okay, so the next row down is all about force diagrams, so free body diagrams that represent the rocket only. So in each of these cases, the blue square represents the rocket, and the black arrows represent the forces that are acting on the rocket, this time before takeoff, this one during takeoff, and this one when the rocket is in orbit. So you can see before takeoff, there is a force acting down and there is a force acting up, and these forces are both 260 newtons. What this row is asking you to do is to label this force diagram with the force names. So when the rocket is just still, not moving, there is a force of 260 newtons down, and you need to think about what that force is called and write it here. Then there is also a force acting up of 260 newtons. You need to think about what that force is called and write it here. Then you need to do the same here. So this is during takeoff, and you can see that the forces are now different. There's a bigger force arrow pointing up and less pointing down. So you need to name this force and name this force and write them onto the diagram. And then once the rocket is in orbit, you can see that there's no force upwards, there is only a force downwards, and you need to label that force as well here. Once you've done that, you can then think about resultant force, size and direction. So if you've got these two forces acting on an object, to work out the resultant force, which is what we're doing here, I'll do this one for you. You take both forces and you subtract them. So we've got 260, that's no good, is it? Hang on. Let's get it a smaller pen. We've got 260 newtons up, subtract 260 newtons down, gives you 0 newtons. So the resultant force for when the rocket is stationary before takeoff, the resultant force is 0 newtons. You need to do the same here and the same here. If you have a force of 0 newtons or a resultant force of 0 newtons, there's no direction associated with that because there's no force acting overall. But here and here, because you will have a resultant force, you need to also state the direction. So is it however many newtons up or however many newtons down? You need to put the direction as well. Description of motion. Motion just means movement. So can you describe for each of these how the rocket is moving in each case? So for this one, how is the rocket moving in this diagram? This is before takeoff. In this box, you describe how the rocket is moving during takeoff based on the image that you've put here. And in this box, you say how the rocket is moving when it's in orbit, and you just describe it as best you can, using as many keywords as possible. Explanation of motion. Well, these questions sound pretty similar. We've got description of motion and we've got explanation. So in this one, you need to describe how it's moving. Explanation means say why. Can you tell me, based on the forces, why this is moving in this way or not moving at all, as the case may be? Can you tell me how the rocket's moving and then say why? Tell me how the rocket's moving and then say why. Use ideas about forces. And finally, identify any interaction pairs. So these are the ones that Isaac Newton talked about when he said that every action has an equal and opposite reaction, or every force has an equal and opposite force. So when the rocket is still, can you find any interaction forces that are happening on the rocket? Okay, so for example, is the rocket placing a force on the ground and the ground also placing a force on the rocket? That would be an interaction pair. So see if you can do that for each of these 3 diagrams. Remember, every time you draw a force, there is an equal and opposite force. So a force in the opposite direction that is the same size. And see if you can describe them in this box. I don't mind how you describe them, just see if you can describe them in sentences for me. And that's basically all you need to do for that activity. If you're unsure, rewind this video and watch the rocket launch again, and use that to help you first draw these diagrams, and then you can start to try and label this force diagram with some force names, okay? So I'm just going to highlight what it's asking you to do in each one. So, draw a picture, label the force diagram with the names of the forces, write the size and the direction of the resultant force, description of how it moves, say why, and then find any interaction pairs. So your interaction pairs are the ones that are equal and opposite. Okay? So when you've done that, you can submit it so that I can see how you've got on, and then hopefully we'll do some practical work on Friday.